Okay, so this is the extended session for logs, so past e-assessment questions. These are just a couple that we've taken. So let's go through some of the answers. So this question you can see is worth 6 marks. So the first question has asked, so it gave us a geometric sequence over here, and it's asked to show that the common ratio is 2. Well, we know that with a geometric sequence, it means it's multiplying by something each time. So if we look at this and say, okay, well, log 4 divided by log 2 is going to be the same as log 16 divided by log 4. Well, it has to be. So if we look at them in a little bit more detail, because we are dealing with logs, I know that I can write log 4 as 2 squared. And then I can bring that 2 to the front, and it's 2 log 2 all over log 2. Because the logs are the same, that means we're going to have the answer as 2. And we can prove this with the second one. You only have to do it one way, okay? This just show how it is one way. So the second one, if you wanted to do it using that, log 16 is going to be 2 to the power of 4. And the bottom one is going to be log 2 to the power of 2. Which would be 4 log 2 over 2 log 2, and then 4 divided by 2 is also 2. Right, then the next question is saying, okay, well, now that we know what the common ratio is, we need to show that this t is the same as the fifth term. So if we want to find the fifth term in the sequence, we know the common ratio is going to be 2. So in this case, it's going to be 2 log 256, but we wouldn't write it as that. We want to bring the power up, so we have to work out what is log 256 squared. Well, we know you can put that in a calculator. It's going to be 65,536. Okay, so we have to show that this is t. Okay, so now that we're dealing with logs, you have the formulas in the formula booklet for the e-assessment. So we know that when we add, we're going to multiply the two numbers together, and when we subtract, we're going to divide. So if I just put this all as one log, okay, so this is for this bit, I need to do 1,240. I'm going to multiply it by 256 and then divide the whole thing by 4. And if you put that in the calculator, you get the answer that we've just got, which is 65,536. Okay, that's the 3 marks. Right, and then the next question says, can we show the sum of the first 6 terms is, find the sum and then give it in terms of log 2. So in this question, we already have 1, 2, 3, 4, 5. Okay, but I'm going to write them in terms of log 2. Okay, so what I mean by that is the first one is log 2. I'm going to add. So instead of writing log 4, I'm going to write that as log 2 squared. The next one was log 16. So that's going to be log 2 to the power of 4. The next one is going to be log 2, and it is 256. So that is going to be to the power of 8. The one that we've just worked out is going to be log 2 to the power of 16. And then the next one, you can see from the powers, 1, 2, 4, 8, 16. Do I have space? Log 2 to the power of 32. Right, so now I'm going to bring all them powers down because it wants it in the term of log 2. So the first one is just log 2. I'm going to add 2 log 2. I'm going to add 4 log 2, 8 log 2, 16 log 2, and then 32 log 2. And now all I need to do is add them together. Remember, there's a 1 here. So 1 plus 2 plus 4, 8, and so on. And we get this 63 log 2. And that's for 2 marks. Okay. Right, we're going to move on to the next one now. So a drag question, 1 mark, super easy. So the first thing I'm going to do then, okay, let's actually work out what this is. We know that we need to divide. So 10 divided by 2 is going to give me log 5. So can't be this one. So log 5, log 5. Right, the next two, okay, they're the same. Okay, so they've just changed log 9 and put 3 squared and then and then they brought the 2 to the front. Okay, so they're the same. So we just have to say, okay, which one gives me log 15? Well, the 3 in this question becomes 5 cubed. That's not 15. But we know when we add, we multiply. So 3 times 5 is 15. So that is the next answer. Right, the next question has gave us some functions and they are both have they both have logs in, so the log functions. So we go down, the first question, which is here for 2 marks, it gave us a point and it wants us to show that in the function g, it wants me to show that k is -1, okay? So it wants me to show this is -1. So all we have to do for this question is substitution. So I'm going to substitute my x and my y in. So this means -2, so the function equals k log 3. And then inside the bracket, I'm going to have x, which is 10. And I'm going to subtract 1. Okay, so I'm substituting them in. So -2 equals k log 3, 9. I know that I can write 9 as 3 squared, which I'm going to do. 3 squared, because now the base is the same. Okay, I'm going to go up here. I am going to write this as -2 equals, if I bring the 2 down, it becomes 2k log 3. We know that when we have this log here, this equals 1. So now 2k times by 1 is just 2k. And then divide both sides by 2. And then we're going to have k is -1. Okay? So then the next question says, well, now that we can have a little look at the graph, we can show that we have 2 functions and we have d is for the distance. Sorry, a little sidetracked. D is for the distance and it wants us to write an expression for d in terms of x. So what I'm going to do is, I know these 2 values here. If I subtract them, it should get me what the distance actually is. So that's what I'm going to do. So I'm going to say, right, log 3, 5x plus 7. And I'm going to subtract negative log 3, and then x minus 1. So we know, because they both have the same base, when we subtract, we divide. However, I'm not going to just subtract. I've made a little mistake there. I need to subtract a negative. So let me just get rid of that. So minus log. So 2 negatives make a positive. And then we know when we add in logs that we times them together. So now I'm going to have 5x plus 7 multiply x minus 1. I need to times them together. So if you expand the bracket, you're going to be left with, if you simplify, 5x squared plus 2x minus 7. Okay, that one's for 3 marks. And then it goes on to say, well, now that you know this, find the value of d when x is 4. Okay, so it's telling me that x is 4. So all I'm going to do now then is substitute that in. So we have log, I'm going to have 5 times 4 squared plus 2 times 4 minus 7. If you simplify that, you're going to have log 3 and inside is 79. And if you put that in the calculator, you're going to get 3.98. Right, let's move on to the next question then. So this question has gave you a question and it wants us to show that we can actually just write this as x equals 2y. Okay, first thing I'm going to do, because it says subtract, I need to divide. So I can write that as log 2x equals log, and then 12y divided by 3. So that means log 2x equals log 4y. Okay, so now they are both just log, which is just base 10, which we don't have to write. That means 2x equals 4y. So if you divide both sides by 2, that means x equals 2y. Okay, so we've shown that. And we can use that in the next question as well. So then it says hence. So that means I'm going to be using this somewhere. Right, so in this question, it says, okay, we're going to solve this simultaneous equation. So this one here, we've just been looking at, I can write that as x equals 2y. Okay, so that's my second equation. I'm going to call that number 2. And then the top one, I'm going to play around with this a little bit because I need to write this without the logs. How can we do that? Well, on the right side, I can actually add in a log 4, because that just equals 1. So if you want to add that log in, if you need to add a log into the question, you can write it with the same base. Now I can bring the 2 up. So I can write this, if I write it over here, as log 4, 3x minus 2y. And that equals log 4 and then 4 squared, which is 16. And now they're the same. I can just write my second equation, the first one. I can rewrite that now as 3x minus 2y, and it equals 4 squared, which is 16. And then we've already wrote the second equation as x equals 2y. And now I'm going to solve. You can solve any way you want. You can use elimination, you can use substitution. This is probably easy to use substitution because we know what x is. So I'm just going to replace 3. Instead of x, I'm going to write 2y. Minus 2y is 16. So that means 6y minus 2y is 16. So 4y is 16. So that means y is going to be 4. And then you can substitute back into any equation. So x equals 2 times 4. So that means x is going to equal 8. And they're your 2 solutions for that question. Right, next question, we have, again, a geometric sequence. So the first question is said, okay, can we determine the rule for 3, 6, and 12? Well, the common difference here is 2, so times 2, times 2. So you have the formula in the extended booklet. So that means R equals 2, and U1 in this question is 3. So if you just put it into the equation, you're going to have 3 multiplied by 2 and then n minus 1. Right, the next question says we have an arithmetic sequence. We have the first 3 terms and it wants us to work out what the next term would be. Well, if you just look at the numbers, you can clearly see it's going to be log 224. Okay. Right, then the next question, again, only worth 1 mark, says the common difference of this sequence, so the common difference each time, is log, and then it wants us to work out what A is. So what is happening each time? Okay, so what's happening to the log each time? Well, in terms of log, they are multiplying by something that's going to be the same each time. So then if we have a little look a bit further, we know that when we divide 2 logs, it's just going to be 6 divided by 2. So in this case, it's going to be log 3. Wait, that shouldn't write like that. That's not right. That ain't right. Let me do that again. Sorry. Distracted. I'm not starting the video again. Sorry, with an arithmetic sequence, it has a common difference of something that they're adding each time in the question. So what are they adding each time in this question? Well, we know in logs, when they add, it actually means multiply. So what did they do to 3 to get the 6? They would have to actually add log 2, because 3 times 2 would give you 6. Sorry about that. Right, the next question then for 2 marks says, let's determine the general rule. Well, you have the formula in your book, which is u1 plus n minus 1d. The first term is 3, and then n minus 1, and the common difference is log 2. So then if we expand the bracket, we're going to be given 3. It's not 3, it's not 3, it's not 3. Doing it again. It's log 3. And then plus n minus 1 log 2 to the 2. Then we're going to have log 3. Then we're going to multiply that out. So we're going to have n log 2 minus log 2 to the 2. Right, and then when I'm going to fix the end bit. So when we are subtracting in logs, we divide. So I'm going to leave the log 3 for now. And I'm going to bring the n up, okay? So the n is going to make that become log 2 to the n minus log, and then just 2. So I need to now divide the 2 to the power of n and the 2. So when we are dividing the indices, so if I write it, we're going to have 2n over 2. We subtract. So then I can write that as log 3. And then we need to add log, I keep missing that 2 at the bottom. It's going to be 2 and then n minus 1, because n minus 1 is just n minus 1. It wants us to write it as a single log. So that just means I need to write that. When we add, we multiply. So it's going to be 3 times by, and then 2n minus 1. And if you notice, it's only worth 2 marks because it looks like this at the start. Right, we're nearly there. I need to change the colour pen because I got a bit messy there. Right, in this one, we're going to be adding. So when we add in logs, it means multiply. So the first one is going to be log 6 times 2 is 12. The bottom one, 16 times 2, is going to give me 32. What's missing in A? Well, if we look here, log 6 and 3, what you times by 6 to get 3, it's going to be a half. Yeah? And then log 16 times log a half is log 8, which can be written as log 2 to the power of 3, which changes to what we have, okay? You can also write log a half if you wanted to. Well, we know that can be log and then 2 to the negative 1, and then you could bring that negative to the front. Okay, so you can write them different ways. Right, last question. We are there. Right, so we know division, so that means 49 divided by A is going to give us log A, not log A, obviously not a log A because I took the log out. It's going to give us A because we know this means division, and I've just taken the logs away. So if we times both sides, it's going to be A squared. So if we